Hi, today is December 31st, 2024. We will continue to talk about R programming. Today, we'll talk about matrices, lists, and data frames. First, matrices. A matrix is just a two-dimensional array of numbers. In R, the matrix can have other types of data. Matrices and arrays are represented as vectors with dimensions. For example, we can create a matrix as follows. First, we create a vector of numbers, x, which is numbers from 1 to 12. And then we specify the dimension of x. C3, 4. That means 3 rows and 4 columns. Then if we print out x, we'll see a matrix like this. So the dimension function sets the dimension x to be 3 by 4. Consequently, x becomes a 3 by 4 matrix. Originally, x is a vector, one-dimensional. And notice that the storage is column major, which means by default, the elements of the matrix are filled along the columns. You see 1, 2, 3, 4, 5, 6. So this is the default behavior, but we have the option to change it. We'll see in a moment. The second way to create a matrix is to use the matrix function. So let's see, we can create a matrix which is exactly the same with the one we just seen using the matrix function. Okay. So we call it M1, and there are 3 arguments, 1, 12, and 3, and 4. Right? By default, the 3 arguments of the matrix function are data, number of rows, and number of columns, where data usually is a vector of values. In our example, the data is the 12 consecutive numbers from 1 to 12. And also, in the matrix function, the elements are filled along the columns by default as well. If we want to change this behavior, we want to fill the matrix in a row-wise fashion, we can add one more argument, by row equals true. Then you see the elements are filled along the rows. Sometimes we might want to add row names or column names to a matrix. We can add column names using this function, COL names, column names. Just list a vector of character strings for the column names. For example, suppose we want to name the 4 columns A, B, and C, and D. We can just use the first 4 letters of the letters vector built in R. Similarly, we can add row names using the row names function. As you see, we add 4 row names to the matrix. Matrices can be transposed using the T function. We actually have seen this before in last video. It's very simple, just lowercase t. After we transpose a matrix, the original rows will become columns. You see, 1, 4, 7, 10 is a row in M1, and it becomes the first column in the transposed matrix of M1. Okay. And similarly, the columns will become rows. I see 1, 2, 3 is the first column originally, and now it's the first row. Yet another way to create a matrix is to use the cbind or the rbind function. Cbind stands for column bind. So basically we combine columns together, or we bind columns together. So you see, we first created 3 vectors, A, B, and C, and then we can just apply the cbind function on them and create a matrix, M4, okay, 3 columns. Similarly, we can use the rbind function to stack them together to create a matrix. So in this case, we will bind them as rows, okay, so A, B, and C. We can also add more columns or more rows to a matrix using the cbind or the rbind function. Just make sure that the dimensions match. For example, M4 is a 4 by 3 matrix, right? Then we can add a column of a vector with 4 elements using the cbind function. So just put the matrix and the new vector. Just make sure the number of elements in the new vector and the number of rows in M4 are the same. Similarly, we can add rows using the rbind function. Next topic is lists. Definition. A list is a combination of objects. Lists are a very flexible data structure in R because the components of a list may or may not be the same data type and they may not have the same shapes. For example, we can create a list as follows. We first create a variable with a single value, x, and then a vector of letters, the first 5 letters, A, B, C, D, E, call it LV. And then we create a 3x3 matrix, call it M. We can put all of them together, wrap them in a list. Just use the list function and then put all of the components in the parentheses, call it L. Then if we print out, we see this is a list. So see, the components of L have different data types and different data structures. So lists are very flexible. And many R building functions return their results in the format of a list. Now let's see how to slice lists. We can retrieve a list slice with a single square bracket operator. For example, if we want to extract the second component of the list, we can use L bracket 2. So then the second member of L is extracted, which is exactly LV, the 5 letters, and the result is a sublist. If we check the class of it, it's a list. It will not return the data types of the data. It will instead tell you that it's a list. And if you check the length of it, it's 1, which means this is a sublist with length 1. If we want to reference a list member directly, we should use the double square brackets operator. For example, if we use L double square brackets 2, we can directly access the 5 elements in LV. If we check the class of the 5 elements, we get character. And if we check the length of it, 5. We can modify list members using the assignment operator, equal or less than hyphen, the assignment operator. Suppose we want to replace A by W in the second component of L. We can just do the following. So L double bracket 2. So this part has 5 letters. And then we refer to the first element, which is A. And we assign W to the first element. So consequently, we use W to replace A. And the last data structure we'll talk about is data frames. So a data frame is a list of vectors of the same length that are related across. So from this definition, we know that a data frame is a list. And the components are kind of special. They are all vectors of the same length. And the data are related across horizontally. So basically, data frames are always 2-dimensional tables. We can use data.frame function to create a data frame from pre-existing variables or vectors. For example, we have 2 vectors, weight and height. Just make sure that they have the same length. And then we can just apply the data.frame function on them and save the result as df and print it out. You see, it looks like this. So a data frame is a list of vectors of the same length. And the data are related across. So each row is corresponding to one individual. So they are related. And how to access components in a data frame? First, we can use the dollar operator. So suppose we want to extract the weight column. We can just say df $weight. Alternatively, we can use the column index using the square bracket operator. So notice that we use df square bracket comma 2. Because data frames are 2-dimensional, we should specify the row index and the column index. But if we want to extract all of the rows, then we leave it open. But still we need to use a comma to separate the row index and column index. Now let's talk about subsetting. First, vectors. Vectors are one-dimensional, so we only need one index to subset a vector. For example, if we want to extract the second component of weight, we can just use the square bracket operator, weight 2, I get the second component. We can also choose multiple elements. If the elements are not consecutive, the indexes are not consecutive, then we should use the C function to create a vector of indexes. And then you see the first, the third, and the fifth elements are extracted. And if you want to extract the first 3 elements, you can use this notation. And 1 column 3 is 1, 2, 3. Next, matrices and data frames. Matrices and data frames are two-dimensional, so we need to specify both the row index and the column index to extract values from a data frame or matrices. So let's see, DF is a 6x2 data frame. I suppose we want to extract the height of the first individual. We should use DF square bracket 1, 1. So first row, first column, so this number. Similarly, if we want to extract the weight of the third person, we should use DF3 too. We can also choose an entire column or an entire row. If we want to select the first row, for example, we use DF square bracket 1, bracket. So again, if we want to extract the entire first row, that means we want all of the columns of the first row, so we can omit the column index, but we still need to use a comma here to indicate that DF is a two-dimensional object, so we still need 2 indexes. Similarly, we can extract the first column. And we can also choose a subset. Okay, so first 2 rows and first 2 columns, which are exactly these 4 numbers. Many times it's very useful to use some condition to select rows or filter rows. For example, suppose we want to choose observations with height greater than 1.75 meters. Then we can use a relational expression in the row index part, in the square bracket. So DF height is greater than 1.75. This expression will yield a vector of true or false value. And whenever the row has a true value, that row is selected. Sometimes we might use 2 or more conditions to choose rows. In this case, we need to use the element-wise logical operators to combine those conditions. For example, we want to choose observations with height that is greater than 1.75 and weight that is less than 80. Then we can combine them using this AND operator. So this element-wise, so only this element-wise logical operators can be used to combine vectors of true or false values. And then you see this is the result. The height should be greater than 1.75 and the weight should be smaller than 80. And lastly, there are 2 functions, built-in R functions, that we can use to choose the first few rows or the last few rows. The head function can be used to choose the first 6 rows by default. And you can also choose other number of rows. For example, you can choose 3 rows instead of 6. And the tail function will show the last 6 rows by default. But you can also choose to show the last 2 rows or 3 rows or 10 rows. Alright, that's all for this video. In the next video, we will talk about conditional flow. If, else, else, if. Thanks for watching. See you next time.